prepped and ready to go. So I click a button and there it goes. We're
Yay.
now live. It was just like that. It was ready to go. Now I've learned another terrible lesson.
What's your other terrible lesson?
Well, I'm always learning terrible, terrible lessons. So, about how things break, how things can't be trusted, how technology is looking to fail me. Oh, you know what? There's a mistake. There we go.
My favorite quote of the day was, "You do realize a RAID away is not a backup drive," to which the person whose RAID array had just died responded, "No, actually, no one ever told me that."
It depends on how they've got their array set up. Right?
There were no backups being taken. And
well, no, but if it's a RAID, I forget the numbers, right? If it's a RAID 0, there's one where you just break up your data onto the two drives, and so half your data is stored on one drive and half your data is stored on the other drive, and it's about speeding up the access to your data. But then,
if 2 of your 3 drives die while you're on vacation when Windows installs updates against your permission, you lose those 2 out of 3 drives of content.
Well, again, so like I said, if you've got them in that configuration, then you have no. It's just about speed. There's no, you're not looking to get any kind of redundancy. But if you put it in a RAID, man, I'm so sorry to everyone here. If you put it in the RAID 1, then it's mirrored.
Right.
And so then you do have redundancy. So then you've got everything is completely 100% redundant. But and then there's like the RAID 4. Man, someone please help me out here. Where you break up the data over 4 drives, but you only get essentially a third of the data over those 4 drives. So the cool thing is
that's what he had done, but he had multiple drives fail, so only one drive survived the crash.
Right, and so you get both the speed improvement and redundancy. So you can lose any one drive out of your 4, not 3. It doesn't work with 3. You can lose any one drive with your 4, and then. But beyond that, you're exactly right. RAID is not a way to.
It's not a backup.
It's not a backup. It is a way to make your computer work faster and make your data work faster. RAID 5. There you go. So you have 5 drives with with one that's a control drive, and then the other ones are data. So anyway, there's different configurations on RAID, but the mirrored one is a backup. And lose a drive and the other drive works, and all your data is still there.
People are commenting on my giant heavy-duty coffee.
Let's see that again. Right on. The coffee cask.
Yeah, it's valid.
Coffee barrel.
My beloved ceramic cups. Our house is so cold that just putting the coffee into the ceramic created cold coffee.
Let me show you what's happening here. Let's see if we can do this. I don't know if this is coming through here, everybody. You all get to see this. It's snowing.
It's snowing in Canada?
Yeah, it's snowing in Canada.
Well, you're in Vancouver, which makes it weird.
Yeah, exactly. It's snowing here on Vancouver Island. That's not right.
Yeah.
Well, it's been the worst. It has been 8 weeks of freezing, like defrost the car every morning, scrape the windows if you want to go anywhere, -8, -10, -12. It's been, it's been unseasonably cold here.
Yeah.
I'm not pleased.
This is going to happen more and more.
Then I'm going to get unseasonably cold. Like, that's my global warming? No, but then I'm going to have ridiculously warm, wet winters too. It's just global weird.
So if you look at the long-term weather models, to totally detract us from recording the episode, the long-term weather models show that places that currently have coastal warming due to warm mid-latitude waters getting carried up to places like you and England, as the salinity of the oceans decrease, those conveyor belts shut down, and you guys end up with latitude-based rather than ocean-based temperatures, which means that you will start to become more and more like Toronto.
No.
Yeah. This is your future. It's way worse in England if you think about how far north they are.
Yeah, they're way more north than we are.
Yeah.
Yeah.
Yeah. England is not the place to be right now for so many reasons.
Yeah. Tom Stranaker is saying it's warm there, +2 Celsius in Sweden. Yeah. Someone said they're out of episodes. Who said that? Cole Morgan said, Fraser, I'm all caught up. It took me 8 weeks, but I need more episodes. Episodes of what, Cole? Are you out of episodes of Astronomy Cast? I find that hard to believe. But if you are, there's 365 days of astronomy. There's all the stuff that you're doing with Learning Space. There's all of the videos that I have over on my personal channel.
Weekly Space Hangout.
We've got the Weekly Space Hangout. If you run through all that, let me know, and we'll make up new shows for you. We will start up whole new episodes. Yeah. We sort of always worry that, in fact, there's too many episodes of the things that we do. So, all right, I'm going to say hi to a bunch of people.
Okay.
Here it goes. Adam Synergy, Avery Goodstory, Carolyn B, Citizen Gold, Cole Morgan, Daniel McCool, David Joseph Wesley, Galaxia, Guido Bibra, Guy Richardson, Hugo Burnham, L. Twercher, J. Pearson, John Suffield, Lillian Brennan, Nancy Graziano, Paul Taylor, Robert Shaw, Roger Haskins, Ryo San, S. Wolberg, Sean Kenny, Sergio Botero, Tech Tang, Thomas Traniker, Tony Raggett, William Vandebeek, and Xander Boy. Hello, everybody, and welcome to a live episode of Astronomy Cast. Xander Boy says, Fraser, I literally cannot go to sleep without having a headphone on with you playing in my ears. We have no problem with that. It's pretty...
Just go back and listen to the part you missed while you were asleep.
Exactly. I don't know about you. I use podcasts to go to sleep.
I use audiobooks, podcasts.
Yeah.
If it's audio, I accidentally trained myself to fall asleep to British voices listening to the BBC.
Yeah.
Which makes listening to science talks given by British scientists quite difficult.
Yeah, whatever. If you don't get any astronomy knowledge out of what we do, but you at least get good night's sleep, our work is done. We have provided you, I think, the greatest gift to humanity that we could. What else is happening? Did I show you my Universal Starfinder from last week? Did I bring that out? No? Here, check this out. Hold on. I have mentioned this in the past, and my dad gave me a box of stuff, of junk that he didn't want anymore, and it's kind of falling apart, so I got to repair it. But it is, let's see if I can bring this up here. So I'll put this on me. Mm-hmm. So this is a Universal Starfinder from 1929, which is cool. And so if you look at it, it has the Andromeda Nebula in it, which is cool.
That's kind of awesome. Now, how do you adjust it for different latitudes?
It's just for, pick the United States, for New Jersey. So,
okay.
Yeah. But it's a classic planisphere. So it's broken, but you turn the, you turn that, and you get the different,
yeah, I love stuff like that.
Yeah, it's awesome. It's awesome. And it still works. It's perfectly accurate. You can totally go out and find the Milky Way and the Square of Pegasus. Here it is. Okay, hold on. Let's see if this comes up. I don't know. Can you too close? There. So do you see that right there? Can you see what that says, Pamela? Right there? It says Great Nebula.
That's kind of awesome.
It has a little X where Andromeda is, the Great Nebula, which I love. So thanks, Dad, for hanging on to this and letting me have it next. And I'm gonna try and clean it up and try and get the little turny bit fixed again so that it'll work as a starfinder. But yeah, it's awesome.
Very cool.
Okay, where were we? Right. We were going to do an episode of Astronomy Cast.
Yes, we were.
Okay. I'm ready to press record. If you're ready to press
Me
record.
too.
Okay.
I am pressing record. Record has been pressed.
I am also pressing record, and record has been pressed. Okay, here we go. Astronomy Cast, episode 438, Geoengineering. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today. With me is Dr. Pamela, the Director of Technology and Citizen Science at the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. How's that title rolling off my tongue?
It deeply amuses me every single time you try and stumble through it. It's long. I'll give you that.
Can we give you a new title? Like, we're in territory now where we can give you, like, can we have, like, the Director of Awesomeness, or, how about Administrator of Space Command? How about...
I think that one's probably not something I want in case, like, an asteroid decides to attack.
The Thrilling Space Agency.
I'd go with, and she codes stuff for CosmoQuest at ASP.
Okay. Is there any, do you have any thing we need to organize? We're going to get straight into fixing the planet after we wrecked it last time.
I think, having discussed the ways to ruin the world, rebuilding it is a perfectly good way to start an episode.
All right, so we know humans are having an impact on planet Earth, but what if we really put our backs into it and intentionally tried to change the entire planet, either to make it better or to fix some terrible mistake we've made? Technique is called geoengineering. Could it work? So again, this is episode 2 of a ongoing series. Who knows how many episodes we're going to get? But we are going to smash up the planet and perhaps the universe, and then we're going to try and fix it, and then we're going to smash it again, and then we're going to try and fix it again. I look forward to seeing how we can fix the galaxy. Ooh, we should do like building like a Type 3 civilization, rearranging the entire galaxy using... Anyway, don't worry about it. I'll pitch
definitely more than one episode.
I'll pitch the episode at you. But don't worry. You'll love it. It'll be fun. All right. So when we talk, and this is like just so in bizarro land, right? We talk about global warming and how we are increasing the temperature across the planet. We are creating unstable weather patterns. We are doing damage to the planet in ways that are, we've not seen in the historical record for tens of millions of years. But don't worry, science got us into this, and science can fix it. So what is the idea of geoengineering?
So the basic idea is you have Earth, that's the geo part, and you engineer it, which is the engineering part. Put less sarcastically, it's the concept of applying the skills of civil engineers, of mechanical engineers, of geologists, all working together, hydrologists, all working together to figure out how to do massive restructuring of the Earth's surface or the Earth's waterways in order to change large-scale functionality of different ecosystems, or perhaps even the entire world.
And we've demonstrated with our chlorofluorocarbons, with our global warming, the temperature increases that we've already seen, we are perfectly capable unintentionally of polluting waterways, of creating gigantic gyres of plastic. I mean, there's all kinds of things that we've been able to do. So I feel pretty confident that we can impact the planet at a global scale.
And the problem comes in going from unforeseen consequences of things like the Industrial Revolution, which completely changed our atmosphere and our ecology, to, well, how do we fix this? And one of my favorite first personal examples of starting to read about geoengineering was the massive work that has been done to try and prevent the loss of Venice. This prior island nation is essentially in a big lagoon that is happily letting its water table go up, up, up. And as that happens, the city that is inches above what used to be the water table is becoming below the water table, which is a bad place for a civilization to be. And so they're working to restructure the lagoons and waterways and drainage systems around Venice, institute locks and dams, and work to prevent further erosion of the city.
And you're seeing something similar with Miami now. They're having to build a giant wall around the seawall around the ocean because the flooding in Miami is getting worse and worse every year, and this is just going to accelerate. You're seeing that in Europe as well. But these are not, I mean, these are like local levels to try to sort of prevent some of the downsides of the things that we're doing in terms of climate change and so on. When you geoengineer, though, like what kinds of projects would you be doing? What's the scale we're talking about?
So smallest level geoengineering is what we were talking about with Venice, where you restructure the massive drainage systems for a river network or a lagoon system. So the Mississippi Delta region, they have major geoengineering projects to try and prevent the loss of the city of New Orleans. But then you can scale things up and keep scaling things up, where we start looking at things like how exactly do we change the albedo of the planet Earth, where albedo is the amount of energy that the planet is able to reflect from the incoming sunlight. So if we want to cool the planet off, can we build stuff that will prevent sunlight from getting to the surface of the planet and let us just naturally radiate away some of this excess heat we've got?
Okay, so let's start there then. I mean, the albedo of planet Earth, how does that impact our temperature?
So the albedo of the planet is a fancy way of saying the sun is shining light at us and we're reflecting away a certain amount of it. The more snow we have, the more of that light we reflect away, the more effectively we're able to keep that ice and snow because things aren't heating up. One of the terrible feedback mechanisms we're dealing with right now is as the ice and snow melts, dirt doesn't reflect so well. Dirt instead absorbs the heat, heats up, re-radiates it in the infrared, melts more ice and snow. And so we have this feedback loop of planet getting warmer because not enough ice and snow. Now, we can do crazy things, and people have put forward the notion of doing crazy things, like putting a bazillion dragonfly-sized mirrors in orbit around the planet that will reflect away sunlight. And it's the light that goes between these dragonfly space satellites. People have supported the notion of, well, in some cases, let's just spread out highly reflective material. This is probably one of the most environmentally bad ways to try and save the environment. People have put forward the idea.
So you just like take a spray can and spray the Arctic white.
Well, paint doesn't do it quite so well, but things like large swaths of white plastic have annoyingly and not legitimately been put forward, much to my amusement and disdain. But this whole idea that we just need to make things reflect better. It's the kind of idea where if we could figure out how to do it effectively and in a way that doesn't disrupt satellite communications, doesn't endanger things that we're trying to take off, it has the interesting possibility of cooling the planet in a way that's fully reversible.
I wonder how you're going to clean up all those little dragonfly-sized mirrors. But I guess they'll all re-enter the atmosphere on their own. So
they're self-cleaning.
They are. So you have to just keep launching them if you want to keep doing this.
And so here it starts to become an issue of, is the amount of greenhouse gases that you insert into the atmosphere launching all of these things going to be sufficiently devastating that this idea becomes counteracting itself? There's lots of caveats on all of these things with changing the albedo. But this is one of the first places that a lot of folks go in trying to figure out how to solve problems with their planet. And it's not just trying to save our planet. People also look to geoengineering to try and figure out ways to generate energy from new sources.
Right. Okay. So I'm just sort of imagining these ideas of like putting out like gigantic white sheets of plastic into the Arctic Ocean. That's kind of crazy. But one of the issues is that we have, carbon dioxide is a greenhouse gas. The more carbon dioxide that gets into the atmosphere, the more you will increase the temperature, the more it absorbs. And we've done whole episodes about this. But the other idea is that you can put other substances into the atmosphere that will do the opposite thing. I mean, we see things like with big volcanic eruptions, enough dust is put into the atmosphere that actually cools the whole planet. So could we go that route instead? Could we create synthetic volcanoes?
So that's another idea that people have thought about. And this is where dragonfly-sized reflectors actually are self-healing a little bit better. But there are folks that have actually looked to figure out. So again, in the idea of these are not things we should actually try, but they're things people have thought about. People have started to look at, well, what happens if we try and trigger eruptions? What happens if we try and look for artificial ways to sequester the carbon that we hadn't thought about? And then we start looking at biogeoengineering. So instead of artificially filling the atmosphere with stuff that changes the albedo, what if we just make it so we don't have to do that by sucking the carbon dioxide out by triggering algae blooms?
How would you do that?
You can do it by changing the chemical composition of the ocean ever so slightly. So basically scatter the right chemicals that is the algae bloom inducing stuff. Now, one of the problems that we're realizing is algae doesn't always do quite what you want. We're starting to hit the point where soils are so warm that root systems, which used to sequester carbon, where the thought was you plant a bunch of stuff, get things growing, the root systems, which get left in the dirt no matter what, sequester it. But we're actually having a change in the bacterial life forms in the top levels of the soil, such that instead of sequestering the carbon, the bacteria are ingesting it and then just outgassing it straight back to the atmosphere.
Right.
So all of these things are kind of in the land of where Descartes said that the ultimate source of sin is acting beyond full understanding.
Right. Well, this is one of those situations where you've got Hawaii, where they accidentally brought the rats to Hawaii, and so they brought mongooses to kill the rats. But the problem is that one is a day creature and one is a night creature, and so they never meet. And so you just get these situations, the unintentional consequences of your big idea. And when you are attempting to affect the planet's climate at a global scale, cane toads are going to look like a walk in the park compared to what kinds of things you might unleash. As I'm shooing European starlings out of my bird feeder, but to go back to the like seeding the ocean with chemicals. I know sort of one of the ideas is just tankerfuls of iron. and you just take these tankers out into the middle of the Atlantic Ocean, dump the iron, and this is the one thing that bacteria needs to have all of the, like, that's the rate limiting chemical in the oceans, and so you just create these enormous algal blooms, and hopefully it sequesters a bunch of carbon, and then it drops to the bottom of the ocean, out of sight, out of mind.
And so the question becomes, what else are we taking out of balance when we do that? And so where I would be concerned with things like that is, how much does that change the thermodynamics of the ocean, which is one of the things that we worry about most with changes in salinity. One of the most terrifying pairs of articles I read, it was either in a single Science or a single Nature magazine back in late 2002, early 2003, sitting on my desk, decided to flip through it. And there was one article on models of, if you change the salinity of the ocean, what happens. And one of the things that happens is the mid-ocean conveyor belts, these great currents that bring the coldest water down from the polar regions and then cycle it up through the tropic regions and then take the warm water up, which keeps England and Vancouver and Seattle and these northern latitude cities nice and happily warm. If you dump a bunch of fresh water into the ocean, you change the salinity, which changes the simple thermodynamics, how much things rise and sink, the buoyancy properties. And the article went on to describe how you could very easily disrupt this system and create a great new glacial period, while the middle parts of the world got nice and overly toasty warm and weren't exactly fertile anymore. So that was nice and traumatizing. And in the exact same issue was an article about how the melting ice sheets are in measurable ways changing the salinity of the oceans.
Right. With unknown consequences. We don't know what changed salinity of the oceans is going to do downstream to the fish populations, to what we depend on to eat.
We know what it'll do to the weather. We don't know what it'll do to the fish populations. We don't know. I mean, clearly, fish that live in one part of the world won't be able to stay put, but we're already seeing that. We're already seeing where coral reefs are dying off because the temperatures have gone up in certain ocean regions. We're already seeing migration patterns that are changing for birds, fish, seagoing mammals.
And I guess this is the heart. This is the heart of what we're dealing with here. Is that we have modified the planet to some extent. We're not killing the planet, right? We always say we want to save the planet, but the reality is, if we weren't here, give the planet a few thousand years and it would reset no problem, as if we were never here. It'll get that carbon dioxide out of the atmosphere. It'll get rid of the ozone layer will replenish, all of the pollutants will be gone, and the planet will move on just like it always was. What we are doing is we are making the planet uninhabitable, or for us, for humans, the way we like it.
And this is where we have to remember, the way the dinosaurs died was a planet-destroying event. If that event happened right now, civilization gone. Mm-hmm. No more civilization.
Right.
And the planet recovered, and we're here.
Yeah, it wasn't a planet-destroying event. It was a dinosaur happiness-destroying event.
Yes.
Yeah.
Yes. And so where we're trying to figure out how to save all of our coastal dwelling populations, while we're trying to save our ability to grow and harvest and hunt and gather enough food for the world's population, we need to keep in mind that's what we're trying to do. And the real risk that we're looking at right now is in some of the worst case models, we're looking at if those mid-ocean conveyor belts shut down, we end up with increased overall heating. We end up with increased cooling in otherwise fertile areas like England. We end up with inability to grow crops in a lot of places in equatorial outwards, the mid-latitudes that we'd previously been able to quite happily grow in. And so we end up with this narrowing band of where do we have a sufficient ability to grow crops. And we also lose all the cities that are happily sitting on the coasts right now.
Right, but this sort of goes back to the geoengineering. I guess the point is that there are amazing, mind-bending ideas about the things that you could do to push back against the kinds of changes. If the temperature is rising across the planet, the temperature rise is due to the albedo. It's due to the amount of energy that is reaching the Earth. Fix those two things. Push on one of those levers, and you will get the temperature to move in the direction that you want it to move, with unintentional consequences.
And so it becomes a matter of what are the connected variables, what are the dependent variables in math terms, and what are the independent variables. So if we create an algae bloom, how does that change the salinity? How does it change the acidity? How does it change all those things that cause me to periodically freak out that I just killed 3 fish due to not noticing the algae bloom in my own personal fish tank? The ocean's a whole lot more complicated than my personal fish tank.
Yes.
But we know that the atmosphere is directly tied to the thermodynamics of the ocean, which is tied to the salinity of the ocean. So now we have a bunch of dependent variables. We also know that the salinity is tied to the melting of the ice, which is tied to the melting of the ice because of albedo effects. So does the albedo become the dominant variable that we need to change? That's where a lot of people are looking. How do we fix salinity of the oceans? That one is just sort of like, well, there's some children's stories out there, but that doesn't help reality.
Put salt in it. Right? I mean, the thing is that when you get to this mindset where you're like, we can just undertake an enormous project. We're going to fill 10,000 super tankers with iron. We're going to dump it into the ocean. We're going to cause algal blooms, and that's going to, once you're at that place, I think you're way beyond trying to fine tune things. This is a hammer that is trying to buy you time to stop the bigger, larger disasters, the runaway situations. What kinds of costs are we looking at to affect some of these changes? Are any of them reasonably priced?
Strangely, the most reasonably priced is probably dumping a whole bunch of dragonfly reflectors in space.
Really?
Which sounds kind of ridiculous, but it's a nice, straightforward, reversible process where we know all of the variables involved in getting it done. Other things that I've heard that seem to not necessarily have impossible prices include things like, let's start pulling the water back out of the ocean where the glaciers are going in and freezing it. So think massive snowmaking machines where you're pulling fresh water out, putting the salt back into the ocean. That starts to look much, much more expensive again, but is technology we have.
Right.
These are things we know how to do.
I mean, that's how a desalination plant works. Is you're pulling ocean water out, you're separating out the salts, you're using the fresh water, and you're dumping the salts. You're putting them in, dumping them in a pile. Why not take them and throw them back out into the ocean to try and balance out that salinity level?
Now, Lord only knows if we can make new glaciers. I
Yeah.
personally find that kind of on the impossible list and much happier with dragonfly mirrors in space. Um, I don't know where to put dumping iron in the oceans on the feasibility scale, simply because that one seems to have so many dependent variables that we don't fully understand that you have to wonder, so is all of that happy little metabolizing life going to generate extra heat we haven't taken into consideration? What is it going to do to all the other populations in there? It's kind of crazy.
What are some of the craziest ideas that you have heard? Ideas on modifying our planet at a massive scale. I mean, your dragonfly idea is already bonkers, but
It's bonkers, but it's bonkers within reach, which I'm fine with.
if you think that launching hundreds of millions of tiny little mirrors into space to float around the planet is within reach, our space exploration program is doing great. Elon Musk is gonna have so much money.
Well, so along that same path, another idea is to put giant solar collectors in space, then tight beam down the energy to basically collection facilities, but you're reducing the overall amount of light generally hitting the planet and focusing it into a special facility designed to go, hi, I'm taking all of your energy and turning it into clean electricity.
Or keep that energy in space. Have space factories that turn that energy into something useful out in space, send the final products back down to Earth. But that again is a level of space solar system colonization that we are so unequipped for, right?
And the problem with trying to use solar panels, solar collectors, giant reflectors that are large solid objects is you need to put them in a larger orbit, a more stable orbit. And that also means they have to be proportionally bigger, because any of you who've ever made shadows with your hand know the closer you are to something, the bigger the shadow to a certain degree. So I mean, it all depends on the light source. I'm talking about collimated light source. Here we're talking about the sun. So if you're looking at okay, this came out wrong, Chad, you're going to have to do edits. So the further away you are, the bigger the shadow you're going to have, but at the same time, the overall amount of area that you're going to have to cover the entire planet, you need bigger things to have the same amount of overall coverage. So if you're close in, you can block 90% of the surface with smaller things than if you're trying to block 90% of the stuff from further out. So this is a very counterintuitive system that is extremely hard to try and figure out how to sensibly explain without drawing stuff. And getting things into higher orbits is more expensive. Building bigger things is more expensive. Getting a whole bunch of little tiny dragonflies in a nice, friendly, low orbit they decay out of at a reasonable rate, it's easier.
I mean, on the state that we're at right now with sort of the political discourse across the planet, we can't even agree. You know, people in various countries can't even agree on that reducing greenhouse emissions are important, that making these kinds of changes matter. I just can't imagine the political agreements that would be required to, for example, expend $10 trillion, give $10 trillion to Elon Musk to launch all your little dragonfly mirrors into space, or to, and I guess, but obviously, you get to a place where it's become obvious that we're past the point of no return, that everything is just going to get worse. Is it then too late? I mean, isn't that sort of the problem with projects of this scale is they won't get approved until it's too late to do them anyway.
This is where, just to be entirely bleak, sometimes you just need a good supervolcano to go off, and the one under Naples is looking pretty friendly right now. Go visit Naples now. It may not be there in the future. The planet does periodically undergo some nice friendly catastrophes that help lower temperatures. But when it comes to trying to fix things on our own, it is the kind of thing where the longer you wait, the worse the problem gets and the harder it is to fix. Looking at the often discussed asteroid issue, if you essentially breathe on an asteroid far enough away, you can deviate its orbit enough that you don't have to worry about it. But if you wait until it's 3 months away from the planet Earth, we may not have the capacity to save ourselves. And that difference in moving something just a tenth of a degree in orbit, that tenth of a degree compounds and compounds and compounds. So the earlier you can do it, the more it matters. If anyone's played, not pinball. I'm sorry, Chad. I'm creating edits due to failing to remember words.
You mean like
pool. If anyone's ever played pool, you know that if the difference between the cue ball and the one you're trying to get into a pocket is 3 inches, you don't have to be as careful with your aim as if you're trying to go across the entire table. We're looking at the types of problems that slight, not exactly on target mistakes add up the same way. If we can do something now that doesn't require the same level of accuracy, that doesn't require the same amount of strength, we can probably turn things around, but it may be too late.
Right. And it's one of those things that, as you say, the earlier you know that the problem is there, the earlier you know that the solution is there, the longer time you have to put in your changes and see them compound over time. But at the same time, the more difficult it is to get everyone's agreement that that's the direction, that's the action that you have to take. If we find that asteroid on its way to Earth and we know for certain it's going to hit us in 6 months, everybody's going to go, what can we do about it? And you'll have as much political agreement as you need to go out and try to stop that asteroid from coming, but it's probably too late. If you find out about it 100 years in the future and it's very easy to make the change, it's going to be very difficult to find the political will to reach out to it until it becomes more and more of an urgent issue. So it's a funny thing. This was not the helpful rebuilding happy episode that I think thought we were going to have going into it.
Oh no, I knew how bleak this one was going to be. I think we need to start, having given up on the possibility of geoengineering solutions ahead of time. Why don't we spend our next episode talking about, okay, we ruined the planet.
Yeah.
How
do we fix the terrible things that we've done?
Sure. Yeah. How do we fix a world that we've given up on?
Sounds good. How do we terraform Earth?
Yes.
I love it. All right. We'll talk to you next week.
Talk to you later. You know, I really need a shirt that says all I want for Christmas is a supervolcano eruption.
But I mean, obviously, you know, there's millions of people living in the Naples area. So how do we get them? How much notice will we have to make sure that everybody's safe and gets to appreciate the supervolcano explosion from afar?
So we don't know enough about this volcano to really know, and I also don't know how good the road system in Italy is to effectively escape something that will cause that much damage. Mm-hmm. Worst case possible scenario right now is there are a couple of Italian scientists who are planning to use essentially oil drilling equipment to drill a diagonal hole, tunnel, drill, well, whatever you want to call it, into the magma chamber of the expanding pressurized volcano. And in this worst case scenario, the magma goes, oh, I have a ready direction I can escape in. You thought your drill had sufficient pressure to hold me back? You are wrong. And this triggers a minor eruption up the drill hole that is enough to lower the pressure. So that's actually best case. Worst case is it goes, the volcano just gives up and is like, I shall explode now. And no one has any warning, because this is literally triggered by a couple of scientists doing something that has many of us going, don't do that.
Wow.
And the whole region goes kaplooey. Best case is the scientists do this, there's a minor eruption and the volcano doesn't go off at all, in which case we get no global warming benefits. Middle case is it starts rumbling, and we get a good 4 days before it goes kaboom, and people actually evacuate the way they should. But Italy doesn't really have evacuation plans set up for if the supervolcano under Naples goes.
Let's see. Lillian Brand wants to know, is there a reputable link for info on the Naples volcano someone can shoot me? I just
National Geographic's.
Yeah, I just read a big article on National Geographic where I found it, and I'm going to read it in more depth. Apparently, about every 12 to 15,000 years, that thing goes off.
This is episode 436
to the Neanderthals, the extinction of the Neanderthals. Sean Kenny says, if enough of the population is educated well enough, could you get the needed support?
Yes, but are we going to get that society?
Yes. Are we going to get a society of philosopher poets, scientists who recognize and appreciate the hard work done by scientists and the overwhelming evidence that's accumulated to take action? I'm going to go from our current situation that the answer to that is no. That we are not in a place where the preponderance of scientific evidence is accepted and acted upon. That we are in the precise opposite of that. Yeah.
I live in the United States right now. I'm not going to say anything other than I want a shirt that says, "Can I please have a super volcano for Christmas?"
Yeah, that's yeah. So I think that's a problem, right? Is that, I mean, we are failing the little problem, which is like, hey, let's stop driving our cars so much. Right? Let's stop pulling fossil fuels out of the ground and burning them when we know that our we know that right now electrical power generation through solar panels is now far more economically viable in literally every part of planet Earth now than fossil fuels.
You can drive around in Greece and there are olive farms, orange groves, cork farms or groves, I don't know what you call a field of cork, and solar energy farms. Yeah. And the fact that just driving through the countryside, they're as common as olive groves now. Mm-hmm. Why don't we have stuff? They make me upset. And yeah. It's one of these things where a lot of the issue becomes socioeconomic, and it's the two tied together.
Yeah.
Because sociologically, we're lazy critters. We want to lounge in the sun and eat what we can reach with our hands without having to stand up and put on pants.
Yeah. Have you ever paid your taxes late? You know, yeah. Have you ever let that thing be in the fridge and go bad? You know,
and more to the point, how many of us are paying for Amazon Prime not to get the movies and the music, but to get our whimsical delivered in 2 days purchases that are destroying the environment, one driver, air freight, cardboard box at a time? I made a determination I'm going to order things only 1 day a week. And this led to 4 separate boxes arriving at my house yesterday.
Yeah, I've gotten some pretty weird. Right. So that's all. I mean, I think that is the problem that we face, which is that we are, we have our individual failings, and those accumulate to a nationwide failing, and that accumulates to a planet-wide failing, and to try to work together. I mean, it's really economic forces, I think, at the largest scales that will save us. Right now, as I mentioned, now it is cheaper to use solar panels to produce your electricity in the United States, in every single state, I think including Alaska, but maybe not, than it is to use any kind of fossil fuel. So literally, if you're trying to make a decision on how you're going to generate your power, if you want to do the one that's going to be cheaper, you're going to choose solar panels, either as a way to generate it for your city or as a way to generate it for your house. And the only reason you're not is because you're nostalgic about the sound of your car.
And it's not just that. It also gets into the short-term versus long-term gain. If we're looking to replace our roof, which we're looking to do because we've owned our house that long, you look at, so what are the prices of the different roofs? If we go with solar or electric getting built at the same time, we're looking at this giant expenditure that takes 6 years to earn back. Are we still going to be in the house in 6 years? And so suddenly it becomes this, can I spend all the money now knowing that in year 7 I'm going to have less funding and it will be a savings then, but I have to tighten my belt until then. And most human beings aren't into delayed gratification.
Mm-hmm. Yeah. And so that's where we're at. But as it gets cheaper and cheaper and cheaper, I mean, the great thing about solar panels is that they are on the technology curve. They are chips, silicon chips.
Yep.
And they are getting cheaper and cheaper and cheaper. And the methods of storing energy is getting better and better with the gigafactory that Musk is creating, things like that. So I think you're going to get to a place where and that there will be, you get your new roof installed and the roofers come by and they say, okay, you want your new roof. Now, do you want the old school asphalt roof, or do you want a solar panel roof, and the solar panel roof is going to cost you half the asphalt roof? And you're like,
yeah,
the one that costs half and gives me energy, I choose that one, please.
Yeah.
And that's the direction this is going to happen. All right, let's take some of your questions here. So if people want to know about supervolcanoes, have we done an episode on supervolcanoes?
I don't know. If we haven't, we should.
Yeah.
So for those of you who don't know, I am slightly obsessed with volcano monitoring for completely I'm a dork that likes to read about volcanoes that you're considering going off and potential catastrophes this will cause. I'm a catastrophe junkie.
Yeah, we all are.
And so I like to go down volcano rabbit holes in my personal time.
We have not done an episode on supervolcanoes.
Okay, so Susie, if you're listening,
can we cue that up? So next week we'll do terraforming Earth.
Yeah.
And then the week after that we'll do supervolcanoes.
Okay.
All right. Did you catch that? I'm telling Susie right now. There we go.
Cool.
All right, you all saw it. I just told Susie. Boom. That's how this works. Okay. That's awesome. All right, let's move on with some more questions. More about supervolcanoes. So, from Dana Nuri, wouldn't a supervolcano worsen our situation if it releases gases that trap heat?
No, the volcanoes, the way it balances out, yes, they do release greenhouse gases, but the amount of ash and soot and other particulate stuff, the stuff that shreds aircraft, that stuff that they throw into the atmosphere, the same quality that causes it to give us significantly redder sunsets is scattering light that is not reaching the surface of our planet, which is what we want that light to do. And in the past, massive volcanic eruptions have done things like cause years with no summer. So you starve for a year or two. Mm-hmm. But oh, what glorious ice grows during that time. I'm a very dark person.
You really are. Arjun says, wasn't there a volcano that was heard 3,000 miles away? Isn't that a characteristic of supervolcano? Wasn't Krakatoa heard that far away?
Yeah, Krakatoa wasn't quite a supervolcano, but yeah, it was pretty big.
Now, you have a supervolcano pretty close to you, right?
Well, it's on the same continent. I'll give it that. So Yellowstone, I want to say, is over 1,000 miles away, which means that when it goes, I won't get buried in ash and lava, but I will be in the zone of we'll be able to hear it and things like that.
Right. But it's going to take out a goodly portion of the United States.
Mm-hmm.
Yeah. And there's others too.
It's mostly an unoccupied but very beautiful part of the United States.
Mm-hmm. And
now, the one to worry about is the not super volcano, but nevertheless a volcano outside of the city of Seattle.
Yeah, that's the one I'm worried about.
Yeah, that one gets you too, doesn't it?
Yeah, it does. Yeah. We've got old volcanoes up and down this coast. You drive when you drive from here to LA, you go past just volcano after volcano after volcano, and they're not dead, they're not extinct, they are all dormant.
One of the most amazing flights one of the most amazing flights to look out the window is flying from Beijing to Seattle, because it's just most amazing mountain ranges. You come down over the coast of Alaska, it's just gorgeous.
Yeah. Larry Beckham's wondering, we're already sort of ruining our supervolcano episode, but are there any evidence for undersea supervolcanoes?
I don't know. I'm going to have to look that up.
Yeah. We will
That's
know
the nice
more.
thing I like about these episodes is I have an excuse to read things I don't otherwise have an excuse to read.
That is awesome.
My dog looks so pathetic right now because he's doing this on his paws. Aww. Because I'm not letting him be loud and obnoxious.
Sergio Botero says, what do we think about the theories that state that major climate changes are due to solar processes and not man-made processes?
So there was actually an amazing infographic on XKCD fairly recently that went through and showed the variations that are due to each of these different processes through several, I want to say tens of thousands of years of Earth's history. And the processes that we're undergoing now due to changes in the composition of the atmosphere are significantly greater than anything that historically has been seen before.
Yes. And the changes are going in lockstep with the amount of greenhouse gases that we're pumping into the atmosphere. At this point, there is 97, 98% agreement on climate scientists. So at the end of the day, you've got to say, you either agree with the preponderance of evidence that the climate scientists are telling us. They are more as certain of this as they are as certain of anything. And so at a certain point, you have to say, we feel that your the conclusions you're coming to have been gotten to scientifically, and we should take action based on what you've discovered. It's like, should you brush your teeth, right? Like dentists in this case have said, we're pretty certain that if you brush your teeth, it reduces the impact of tooth decay. So we recommend that you brush your teeth. And I say, thank you, scientists. As a person who doesn't like to get cavities, I will brush my teeth mostly.
And one of the things that to me is terrifying is I know lots of planetary scientists. I know lots of planetary scientists who study our atmosphere and the atmospheres of other worlds. And I don't know any atmosphere studying scientists who have children. And I know lots of not child having planetary scientists where their reason is they just can't add another human that would have to experience the changes we're undergoing to the planet.
But look at that dog. Aw. Is Olympus Mons a Mars supervolcano? Asks Arjun.
I need to look up the fine line defining what a supervolcano versus a regular volcano is. It's sort of like the nuances between a brown dwarf, a red dwarf and a regular star?
People are saying there are undersea supervolcanoes. We're going to get to the bottom of this in 2 weeks.
Yes.
Oh, we're going to do next week's episode at a funny time, right? It's going to be Wednesday because you're on the road.
Yeah, so I'm going to be at Furman University next weekend giving a colloquium talk in the evening to the Astronomy Club. So if you're near Furman University, follow my Twitter. I'll let you know when I know all the details on it. Right. And so we'll record early.
This is great. David Joseph Wesley said 4 to 5 dentists are terrified of supervolcanoes.
You know, what's wrong with the 5th one? Do they not know what supervolcanoes are?
That's awesome. Yeah, one out of 5 dentists are stupid, says Larry Beckham, which is awesome. Okay, cool. All right, well, let's wrap this up. Thanks, everyone, for watching. Thanks, of course, to the WCH crew for providing the chat down here and bringing in all the questions over there. Thanks, Pamela, for giving us existential dread and terror. Next week,
hey, I gave you something new to be afraid of.
Next week, we're going to fix it. We're going to fix it all. We're going to bring it all back and set it all right. So, all right. I'm trying to think if there's anything else. Oh, I'm going to do a live stream on Monday for no particular reason. So, go to the Universe Today channel. Join me on Monday. We'll hang out and we'll talk.
Sounds good.
We'll see you all next week. Bye.
Bye.